The function f mapping r to r is defined as follows. F of x is equal to 3x squared if x is rational, and negative 5x squared if x is irrational. Which of the following is true? Okay, so a question like this, I typically like to go through each option at a time and figure out one by one which statement is true and which is false. Let's quickly write down the function f of x so we can refer to this when we need to. Okay, and as a little bit of a graphical representation, you can't really trace what this function looks like, but it looks something like that for rationals and something like that for irrationals. So if I look at the first statement, f is discontinuous at all x, that statement is false because this function is in fact continuous at 0. I'm not going to go through in too much detail exactly how I know that, but if you look at the definition of continuity, the strict definition of continuity, if you look at the strict definition of continuity, if I put an interval like this around 0, I can always guarantee that the function lies within that interval by choosing something small enough around 0 horizontally like that. So A, this statement is false. Okay, statement B, f is continuous only at x equals 0 and differentiable only at x equals 0. So I'll have to come back and think about differentiability. So it's definitely continuous at 0. I'm going to come back to this because so if I look at the rest of the options, they're all about continuity and differentiability. This is the only options B and C are the only ones that could potentially be true. I'll come back to those. So option D and E are also both false. So I'll read out option D. F is continuous at all rational x and non-differentiable at all x. So this function is not continuous at all rational. It's clearly not continuous, at this value of x, because arbitrarily small changes in x can give us quite large differences in the function. And option E is also false for the same reason. So now the only thing we have to think about is whether this function is differentiable at 0 or not. We know it is continuous at 0. And I think it's probably also differentiable at 0, and the derivative would be 0. But let's write out the definition of the derivative. So f prime of 0 would be equal to the limit as h approaches 0 of f of h minus f of 0 divided by h. So this is the limit as h goes to 0 simply of f of h over h. And this is, so if we think about taking this limit for rational values or irrational values of h, regardless of which sequence of numbers we take, if we don't think of h as, if we think of this as like a limit of a sequence of points, where h is a sequence of numbers approaching 0, it doesn't matter whether we approach 0 along rationals or irrationals. If I write this out as suppose h is only rational, then this gives us 3h squared over h, which goes to 0. And on the other hand, if we suppose h is irrational, then we have negative 5 h squared over h, which also goes to 0. Now this isn't like a full proof exactly, but regardless of what the value, whether the values of h are rational or irrational, as they get closer and closer to 0, this ratio also gets closer and closer to 0. So for that reason, option B is going to be true, and option C will be false. So, yep. I mean, I didn't even look at all the statements before starting this, but if I looked at all 5 statements immediately after reading the question, I immediately would have realized that either B or C is correct, and very good reason to believe that B is correct, because you're kind of you're sandwiched between two functions that both have a derivative of 0 at 0. Yeah. Anyway, this is working it out from the definition shows that this is differentiable at 0. But 3 of the 5 statements can be eliminated very quickly. So yeah, I don't really have much more to say about this one. But if I think of anything, I'll put it down in the description. Thanks for watching.